Wahahaha. Pretty good, right? I feel like a really spooky witch. All right. Hi guys, this is Professor H2O with Nutty Scientist. Welcome to our lab. We have a show for you today, and it may look different than our normal shows, but we're gonna have lots of fun because I've got all kinds of cool experiments to show you today. All right, so I'm with Nutty Scientist. Nutty. Anybody know what that means? It means that we're a little bit cuckoo. No, we just like to have fun. So some of the stuff that I'm going to show you today, it is a little silly, but that's what makes it good, right? So I have to tell you my nutty thing that happened to me. So I was working in my lab, and suddenly I heard a knock at the door. Who could that be at this hour? So I go to the door, and it is my favorite person to see during the day. Anybody know? The postman. He brings me all my Amazon Prime packages, all my experiments, all my balloons. Look at this guy. So he was there with a very important letter, and the letter invited me, Professor H2O, to Australia. Australia! I've always wanted to go, so I was already excited. They wanted me to go to Australia and present my scientific invention. And I was really, really excited. And I started packing all of my things up, and then I thought about it. Australia. That's not somewhere you can walk to. I would have to travel. I didn't really like flying. A way to get to Australia without going on an airplane. And then I thought about it, a boat. I love water, right? I am Professor H2O, which is a fancy word for water. So I decided I was going to go on a boat to Australia with all of my inventions and my scientific materials, and then I could present my super special secret item at their conference. So I get on the boat, and I'm, enjoying all the sights. It had water slides, it had the buffet, it had the science lab where I got to play, and suddenly we crashed. And I looked, and we were on a deserted island. No, that's not an ice cream island with brownies and cookies. Deserted means that there is no one else there. So I looked around. Luckily, my experiments came with me, and I had to figure out how to get rescued. I needed to do this really quick because I wanted to make sure that I got to Australia on time. So I decided the first thing that I should do is try this thing I saw on TV once called message in a bottle. Have you guys heard of it? You send a message out to sea, and then the ships that are passing by, they find it, they open the bottle, and then you can tell them that you are, and they can come rescue you. So I decided to write my own. I said, "Dear, people on the cruise ships, help! I am trapped on a deserted island. There's no candy, and I really need to go to my conference. From Professor H2O. P.S. I'm at the fourth palm tree from the left. Thank you. Bye." And then I rolled it up, and I put it, what do you think? This one's nice and big, but it's breakable, and the water might be able to go in because it doesn't have a cap. Let's try, we'll put it in this one. So I rolled up my note, I put it in here, sealed it tight so that it didn't get all that water in there. All right, I gotta warm up my arm. It's gotta go really far. It's gotta make it all the way out there to those boats. Not so good. Maybe I can use science. I'm always better with science. So I decided to use science to try and launch it into sea, and hopefully somebody would find it. All right. So I have here something I carry with me at all times, my personal air conditioning system. So it may not look like much, but wait till you see this thing in action. When I pump it down, what does it usually do? People buy these to fill up their tires with air. I use the air for something way more important. Nice and cool. But today we're going to use it not as my personal AC system. Well, it probably will because we're on an island and it's hot. But first we'll use it to try and launch my bottle. Whew. So right now, this bottle does have air in it already. Even though you can't see anything in there, it's got empty space, so we know that there's air in there. What I'm going to try and do is pump more air. And I'm going to pump more and more and more until the bottle can't take any more air and it'll blast off into the ocean. Sounds right, right? Sounds like something we can do. All right, make sure this is good and tight. All right, here we go. Ugh. All right, did we do it? I don't think it went far enough. And there goes one of my bottles. That's gone. Luckily I had this one. And the responsible scientific thing to do would be to try again. But I didn't do that. I got very angry. I did something I should never have done. I took my bottle and I said, "How dare you betray me? I was expecting you to do great things." And I smashed it. So this is now my new bottle. It would have been really smart to save this bottle in case, I was thirsty or something like that. But again, I got angry. Doesn't look so good. But I tried to fix it. I really think that this bottle will come in handy. And I used one of my very favorite things to try and fix my bottle. Some of you guys, if you have seen Nutty Scientist before, you know this is one of our favorite things to work with. All right, so let's see. We're gonna try and get our bottle back together. We're going to use one of my favorite things. Ooh. Dry ice. Who knows about dry ice? Hopefully a lot of you, because this stuff, there's so many things you can do with it. It's simply amazing. The first thing I have to do is put on all of my extra equipment. My gloves and my glasses. This stuff is so dangerous. If I touched it with just my bare hands, it is so cold, it could burn me. It's not hot. It's cold. It's kind of like freezer burn. This is 100 degrees below zero. And this ice, unlike your normal ice that you get from the refrigerator, when it melts, it doesn't turn into water. It turns into a gas. So there it is. If you look really closely, you should be able to see all the gas. That's called sublimation. It's turning from a solid to a gas. And there's some things that we can do to really be able to see that sublimation happen. So before I fix my bottle with the dry ice, I'll show you some really cool sublimation tricks that I know. Sound good? All right. We're just gonna set this guy right here. The first thing we're gonna do is we're gonna make this sublimation into a mist. Ooh, spooky. All right, here we go. Check it out. So this water is warming up that dry ice and it's sublimating super fast. And there we have it, the mist. It kind of looks like a cloud. One question that we get all the time is if I put food coloring in there, will that change the color of the smoke or the gas? And the answer is no. If I put this in there, it'll change the color of the water, but not the gas itself. We might as well try it since we've got all this food dye right here. We'll use some blue. And look, you can see the water underneath change, but not the gas. It's also pretty cool because you can make it look like it's spilling over. Let's see it. They use this stuff in special effects for movies because instead of getting all in your face like fog, it goes towards the ground so you can like pour it out like that. How awesome. All right, I'll show you in this container too because the gas takes the form of the container that it's in. So let's add our food dye first. This one we put in some blue. Oh no, already I'm a mess. I told you I was nutty. All right, let's add some red this time. This is one of my favorite things too. It's called Diffusion. I like that it dances through the water. Isn't that pretty? Let me move this closer so I'm sure you guys can see it. How awesome is that? But as soon as I put that dry ice in there, it's going to mess up my diffusion. That water is going to get moving real quick. All right. Gloves back on. Might as well keep them on. Maybe that'll keep my hands a little bit cleaner. Let's see. This chunk looks pretty good. Oh, maybe a little too big. All right. Watch out if you're in the splash zone. Up, too big. Oh, man. Wow. I was in the splash zone that time. Wow. I hope you guys can hear that because that is fantastic. I need this as my alarm clock. But you see, if you can see up here, I can touch this. I can even touch the water, and that's not going to burn me because I'm not touching the chunk that's below it. Pretty awesome, right? So what we want to do to try and fix my bottle that I broke is we want to capture this gas so that it expands my bottle and brings it back to normal. Let me just clean up all this mess I made. We want to keep the lab nice and sparkly. All right. So for this, obviously I put some really big chunks. Oh wait, I forgot. One of my favorite things to do. Are you ready? I told you it was spooky. Pretty good, right? I feel like a really spooky witch. All right. So we put big chunks in here. I don't think you can see it through this. We just need little tiny chunks. And then we're going to put the cap on, trap all the gas that's coming in here, and hopefully it'll bring my bottle back to normal. All right. We'll see if we can do it. Probably the easiest way is to use this scientific tool, the funnel, to get these little tiny pieces of dry ice in the bottle. Let's see. Ooh, that worked well. Let's see. If you notice, these pieces are a lot smaller than the chunks that we put in there. Those look like little icebergs compared to this. If you notice too, this stopped sublimating, and that's because the water has gotten so cold that it's not reacting anymore. So maybe if I put some more water that's room temperature in, there it goes again. Pretty cool. All right, so now we have our chunks of dry ice in our broken bottle, and we're gonna see what they can do. We're gonna try to capture that gas and expand our bottle. To do this, we're gonna add some movement. Ready? You see the bottle blowing back up? It's helping me out. Wow, it's almost like magic. All right, but listen closely. You may be able to hear the gas escaping the bottle. Ready? Did you hear it? It was really quiet, but it sounded like you're opening a soda. And that's because the dry ice is really just frozen, squished down carbon dioxide. And when you think about a soda is what? It's carbonated. Just like the dry ice contains carbon dioxide, your soda uses carbon dioxide to give it those awesome little bubbles. No, there's no dry ice in your soda, but it's the same gas. Just not so frozen. All right, so, oh my goodness, we've got dry ice everywhere. What we can do now is maybe see if we can capture some of this gas even more. All right. By this time, I was getting a little thirsty, and I hadn't really seen anything besides the ocean water, which doesn't taste very good. So what I decided to do is try and capture, funnel, there we go. Try and capture the dry ice gas to lift me over the island and fly me so that I can maybe find a freshwater lake. Sounded good at the time. So if only I had something that would capture this gas, lift me up into the air so that I could search my island for something to drink. This water's salt water. We don't want to use this either. All right. What color balloon do you think we should use? I think we should go blue. Oh, we've already done blue. Let's do pink. Gloves off. All right. 1, 2, 3. All right. So my plan, wait for this thing to inflate. It's going to lift me up over the island. I can search for all the lakes, and then I'll have fresh water source that I can drink from. Get that sublimation going. I think this is probably good enough. I think that if I get a running start, it'll just keep me going. Ready? You think that'll work, right? Sounds like a good idea to me. I mean, balloons, you've heard of hot air balloons? This is just a cold gas balloon. Different, but the same. All right, ready? 1, 2. Nothing. Good scientists always know, though, try again if it doesn't work the first time. All right, 1, 2. Still nothing. So that means that there's either two things wrong. 1, this gas is not the type of gas I need to lift me up into the air. Or 2, we need a bigger balloon. I think we just need a bigger balloon. I think that if we had a bigger balloon, it would work. But at Nutty Scientist, we do not let any balloon give us its life for nothing. We have to set it free. That's our favorite way to get rid of balloons. You ready? 1, 2. There we have it. All right. So, bigger balloon. And I think I've already given it away. I may have some. So, I could put this balloon over this and wait like a couple hours. Do you guys have that amount of time? That's okay. Let's see. I think maybe I have something else. I don't think it'll reach over that. Let me look. I think I know just what we need. I brought the biggest bottle that we had in the lab. Let's see. It's already got some dry ice in it. You think we need some more? Let's add a little bit more, just to be sure. It's got to fill up this whole balloon. Gloves. All right. Look at this. It is a volcano of dry ice goodness. I really think that this balloon is going to do it. You ready? You sure you can handle it? I mean, it is a pretty big balloon. All right. Let's see if we can really get this going. And don't worry, I'm going to take it off before it pops, okay? So if you look up top, you see that there's a little bit of space up here. That shows me how much space the balloon has before I have to take it off, because it could explode if I put too much air in there. But I'm a balloon expert, so I think we're okay. All right, you think that's big enough, or you think we should keep going? What's also good is that if this was fresh water, it would make into a carbonated water. So right now, all this water is getting carbonated. It's getting all that bubbly and fizzy taste to it. Wow, look how big this is getting. I think we've still got space though. If you look at the top, it's a nice dark purple. I guess it's a bad sign that I'm not lifting off the ground yet. We'll find out. All right, we will count and do 5 more seconds. Ready? 1, 2, 3, 4, and 5. All right, now I just need to figure out how to get this thing off of here. There we have it. Am I flying? Maybe I just need a running start. I was really hoping that this would work. Ready? 1, 2, 3, 4, 5. Nothing. That's very disappointing. I really thought these big balloons were going to send me flying for that water. All right, well, you know what we have to do. Can't leave this balloon filled with this gas forever, right? I think we should go straight up this time. Whew. Whew, that was gassy, literally. All right, so let's move this out of your way. So no, I'm not currently on fire. If you see gas, it may just be dry ice behind me. All right, well, I couldn't find the water the easy way, so now I had to go the hard way, walking around. So I walked over my island. I was still very, very thirsty, and suddenly, in the distance, I saw it, a crystal blue lake. It almost looked as blue as this. It looked like the most beautiful, pure water that I had ever seen in my life. So I run down to the lake, and I get my cup, and I go in for a nice big gulp. It was solid. The water, it wasn't frozen water. It was just solid water. Somebody was playing a very mean trick on anybody that landed on this deserted island. I'll show you the trick using a little magic of my own. Before I show you our magic trick, let's first clean up our workspace. As scientists, it's important to always think about your workspace and what you have in front of you. It would be really awful if somehow one of your chemicals reacted with another one. That would just be bad news. And it's just nice to have a nice clean area. I'll still need some of this stuff. We have lots more experiments to do. Oops. Need this so you can see. I'm going to show you how they turn that lake into a solid lake. Without freezing it, nothing. First thing I'm going to do is add a little bit of water. Give it a good swirl. I'm sorry, swirl, not squirrels. Add a little bit more. And hopefully we don't need them, but let's have the paper towels ready. But you guys are going to be such great scientific magicians. I know that we'll get this right first try. I'll try first, and then I have a special guest professor that maybe wants to try the second one. So what you're going to do is you're going to say the magic words with me. Are you ready? Once we say the magic words, this water that I poured into the cup will turn into a solid, and then I will stay very, very dry. All right. Alakazam, alakazoo, turn this water into solid soon. You think we did it? You think it's a solid? I sure hope so. I sure hope you were saying these magic words with me. Look, we did it, right? It's solid? Not solid. Are you guys sure you were saying the magic words with me? Luckily, we have one more try. It's not looking good, but I think we can do it. But I told you, we have a special guest professor. And I love H2O. H2O is my favorite. But this professor doesn't like H2O, or water, as much as I do. Let's see if I can find her. Professor Molecule! Come here, Professor Molecule. I think I hear her coming. Has anybody seen her? Small. Furry. Here she is. This is Professor Molecule. She doesn't like water near as much as I do. But I think that she'll be able to handle it. I sure hope you guys did your magic right. All right. Say the magic words with me. Ready? Alakazam, alakazoom, turn this water into solid soon. Please, please, please let this work, right? Wow. They must like you better than they like me, Professor Molecule. Nothing. You guys did it. But I may have played a little tiny trick on you. So the first cup, it's all water. You see it? The second cup, I added a little bit of an absorbent polymer, so it's actually a solid. That's why I didn't dump on Professor Molecule's head, because it was a solid. I added a little bit of powder to turn it into a goo. And that's just what happened to the lake. Somebody filled it with these absorbent polymers, and then this is what the water turned into. Gross. You guys know that you've all touched this stuff hundreds and hundreds of times. This is what they use in diapers. Gross, right? But just imagine if they didn't use it. That means that all that liquid would go everywhere. So after I figured out the trick that was being played on me, I did walk around and I found another lake that worked just as well, that didn't have a magical curse on it, so I was able to find some water to drink. And then I started to feel a little bit hungry. I was trying to look. I don't think I could eat dry ice. That wouldn't be very good. But I think I did pack, there it is, a snack right here in my pocket. So I could eat this now, or I might think about that I may be hungrier later, that I maybe want to eat that then. So I decided that instead of eating this now, I would try my hardest to get to wait and see if I can eat anything else that I see on the islands, like fruits or bananas, something like that, and save this for later. So I just wanted a safe place to put it. I mean, I could put it in this, but then I have to carry this big thing around with me. I really wanted to keep this with me in case an animal found it. I think this will do. This is nice and protective. I can walk with it easy, and then no animals are going to stick their heads in there and eat my egg. So let me just keep it in here so it's nice and safe. Uh-oh. But we were so close. It's not going to work. But once again, I'm a scientist. I have to think like a scientist. And I think I know a trick that just might help me out. So it does involve fire, but luckily I'm a scientist and an adult, so I think it'll be okay. All right. So what I want to do is I'm going to put a fire in the bottom of my cylinder, and then I'm going to put the egg on top and suck it in, because all the oxygen is going to be eaten up by the fire, and it's going to pull the egg down so that I can keep it in here for safekeeping. You think that'll work? I don't know. We'll have to find out, won't we? Science, as long as you're safe, you gotta try different approaches until something works the way you want to and gets the results you need. All right, so I'm gonna have to do this real fast. Usually I use a helper, so we'll see how this goes. All right, so let's see if it'll work still. You see it's pulling the egg down, sucking all that oxygen, and there we have it. Look at that. Wow. All right, it's getting a little dirty. I'm hungry now. I think I need it. I tried to wait. I really think that now is the best time. This is gonna be the hungriest I'm gonna be on this island. Let me get these cotton balls out. All right, perfect. Egg time, egg sandwiches, egg salad, omelets. Can you believe my luck? This is just not my day. Now my egg has burned stuff all over it, and it's stuck in there. I do have one thing that maybe work. I saw it at another scientific convention. Let's see. So what I want to try to do is push air up here and fill it with air so that it pushes the egg out. You think I can do it? Let's try. Oh, it's so close. Come on, little eggie. This is a big egg. This is going to be delicious. There we have it. Wow, they're really making me work for my snack here. And some of you may ask, is this a real egg? The answer is yes, it is a hard-boiled egg and a delicious snack. Maybe not the burned sides, just the part that's not burned. All right, I'll save that for later. It's gonna make me really hungry in order to eat that dirty egg. Maybe I'll wash it off in the lake later. All right, so I had my water, I had my snack. I tried to blow around the island in a hot air balloon. That didn't work. I did my dry ice experiments. Overall, it hasn't been a bad time on the deserted island. But I did end up getting rescued by a local boat. They saw my egg experiment, the fire, the flames, and they came right over. And I hopped on, and I got to go present my scientific experiment in Australia. Do you guys want to see it? All right. So it was sitting right here the whole time. I don't know who of you had noticed it. All right. So this time it's going to be a little bit of a different powder. Let's see. First thing I want to do is add my water. Maybe let's just add half of it. Now for the fun powder. This isn't any diaper powder like last time when I tricked you. All right, let's see if anything happens. Keep your eye on the water. Let's see if anything happens when I dump this powder in. You see anything? Look at that. This is absorbent powder for snow. This is how they make the scientific snow. You see it expanding? All right, let's add a little bit more water. Actually, we'll probably just put all of this in there very slowly. Look at that. How awesome. We are making scientific snow. The scientists in Australia thought this was really cool. I love scientific snow. There we have it. Give it a good shake up. Some of that snow hasn't touched the water yet. It's got to absorb. Wow. You think we should make a mess? I really do hate messes, but for you guys, we'll do it. Let's see if we can dump it out. Oh my goodness, they're gonna make me get really messy. Does it look like it's snowing? Here. A little clumpy, but this looks like snow. A snowstorm, maybe. And there we have it. Look at all of my snow that I created with that little pack of polymers. This looks like it's enough for me and Professor Molecule to have a snowball fight later. Does it look like real snow? Who says we can't have Christmas in the summer in Florida? Wow. This is just, I wish you guys were here to feel all this. This just feels so soft. Maybe when we're back together again. But wow, what an exciting experiment. And see, there goes the mess. But the beauty at the at-home lab is I don't have to worry about the floor of wherever we are. I can just mop it up and not have to worry about it. Kind of looks like rain a little bit too, huh? But thank you for listening to my story. I had a great time with you guys today, and I have a great night ahead of me playing with all of this snow. Me and Professor Molecule, she might have to roll in it later. She is going to love this. Wow. All right, guys. We'll see you next time, okay? Bye. Strange things are happening on this island.